Okay, hello everyone. So in this video, I'll show you and teach you how to use the Python memory model. So the first thing to actually call this is a Python memory model. The reason why is because you don't really say the Python memory model, even though sometimes you can. The reason why is because this is more like a technique to basically keep track of very important things, very complicated things which happen in the background of your computer when you're actually looking through Python code such as this. So I'll actually go through an example of how to use the Python memory model using this piece of code as my primary example, but for now I'm going to give you the blueprint, which is a set of rules that you need to follow this technique to use the memory model. So it's just a bunch of rules and a blueprint that I'm going to show you first. Maybe I'll refer to the example a bit, and later on I'll actually go through the example properly on how to show you actually how to use the memory model so that you could do this with yourself. So here's a summary of the Python memory model. There are different ways to do it, but I'm just going to show you the way I do it, the way that I find easy and simple. Once again, it's up to you on how it all works. So here we go. Let's get started. The first thing you want to know is that you basically make these two columns. These two columns are going to represent what's happening in front of your code and at the background of your computer, of your memory, basically. So also I'm going to keep track of my output over here. So the output is just whatever your code prints back at you. So it's the stuff like, let's say you put like hello world, you do print hello world, then you're going to have hello world over here just to show you that it's being printed back at you. Okay, so these two columns. So this one is for the variable space. It's where you store all the global variables, well actually all the variables in your code as you trace through it, as you go line by line. Over here is the memory space. So here's where you store all the hardcore data, like so like the number 3 or the string hello world. It's where all the stuff in memory is actually stored. So here, in variable space, you just refer to it. You point to where it is in memory. So some variable will point to something here. So I'll show you how that works right now. So you're going to have some variable, and it's going to be assigned, or it's going to refer to some ID number, which is just an address in memory space. So that should basically denote that address, which is over here, is storing that something. So in other words, x equals hello world would mean x points to some ID number. Let's say ID 0, and ID 0, as we see over here, will go over here. ID 0 will point to hello world. So hello world will be that something that we're storing. So this is just one. This is just a blueprint. That was just one example of how variables get stored, but all variables will get stored like this. You'll have some variable. This is the format. Some variable, some ID number. That ID number will point to that something. So then you ask the question. So again, this is all the global code from line 5 to line 8. It's all in global space. It's the global code because it's not under a function. Everything that's underneath a function is local to that function. So you see how this is indented? This means that this stuff, these two lines of code, are local to this function. So how do we deal with functions? Well, again, these were just the basic rules you have to follow to keep track of global space. So here are the basic rules for keeping track of a function. When you call a function, which means you're using a function which you defined earlier. So you define the function here. It's just a block of code that you're using, right? It's just a block of code which you'll be using later on, and you actually call the function over here. Don't worry about what this function is doing for now. It's just, even though it's very simple, I'm just going to show you what happens when that function is called, or any function is called rather. What you do is make a box like this to denote local scope. So in this local scope, everything that happens in the function will stay here, and you can't leave this box. You can't leave this scope until you see a return statement in the function. If there is no return statement, we'll just return none. Then you can leave once you see the return statement, or you reach the end of the function. Otherwise, you have to keep doing everything in here, all your variable assignments in here, and you can't leave this box. So over here, you're going to store the function name. Over here, you're going to store in the return value, and over here, you're going to store the local space. So all the local variables local to this function. So again, the same stuff that happens here is going to happen here also, because you're going to have some variable that's going to point to some ID number. That ID number is going to store that actual thing in memory space. So for our reference, once we go through the function line by line to the very end of the function, we'll get what it returns, and we'll store in this box over here what it returns. Over here, we're just going to store what the name is for our reference also. And we'll see everything here in an example in just a little bit. Once you're done with the function, we'll also see that you can erase it or cross it out as you see fit. Alright, so now for a very quick and easy example of how to use the memory model. So I'm going to use this code right here. So there's my box, and over here I put the function name. The function name is sum right here. So I can put sum here. Let's just put let's say like that, and then I need my return value, but I don't know what it's going to be just yet. I need to actually go through the function line by line. So I know I'm here in this line first, and this function is called. So I jump back here to line 1. Now I'm at line 1. So to show that, basically, it will look something like, say something like this. I'm here right now, and I'm going through this function because I jump back to line 1 because of this call over here. So once I go there, right here, I notice that there are two parameters, x and y. We call these parameters when to a function. We call x and y the parameters of the function. We'll know that since this is line 1, line 2, and line 3, and even though the Python compiler and interpreter does go line by line, what it also does is notice that all this is just a function definition. In other words, it's just local code. It's local to that function. So we're going to skip all of this. Why? Because it's local to that function, and we only care about the global code. We only deal with local code once we call the function. So we're at line 5. So as we go straight down to line 5, we apply all the rules of the memory model. So the way I do line 5 is I just do first num is equal to 3. Okay, well that's just first num pointing to, let's say, ID 0. Let's pick that as my first number, ID 0. Okay, then in memory space, it's very simple. It's just ID 0 is really just storing the number, as I said, the number 3. Okay, and we're done with that line. Okay, so going on to the next line, line 6, it says second num is equal to 8. Alright, that's also pretty simple. So we just do second num. And this time I need to pick a different ID because I've already used ID 0, and I need to pick a unique ID, unique address for the number 8. If I was using number 3 again, then I'd just put ID 0 here. So again, if I just had the number 0, I'd put ID 0 there. But since I have a different number, I have the number 8, I'm going to make this ID 1, so that over here, ID 1 is storing 8. So just like that, we're done that line also. Okay, and for the next line, we've got a variable result, which is pointing to some address, and it's going to store something, but we don't know what it is yet. First, what we have to do is figure out what this function returns. I know that sum of first num, second sum returns something. Whatever that something is, I'm going to store it in result. So in the memory model, the way I deal with that is